When Donald Trump took office as the 45th President of the United States, one of his boldest moves was imposing tariffs on Chinese goods, igniting a trade war between the US and China.
We are the piggy bank to the world. We've been ripped off by China. We've been ripped off by, excuse me, Mr. President, the European Union. We've been ripped off by everybody.
But that wasn't all. The US had another major objective: to prevent advanced technology from reaching China. In this effort, they struck China where it hurt the most, by imposing strict export controls on cutting-edge semiconductor technology by targeting Chinese manufacturing giants like SMIC and Huawei. But it didn't end there. The US also exerted its influence on key players like Taiwan and the Netherlands, pressuring them to stop supplying critical technology from companies like ASML and TSMC to China. But the real question is, why didn't the US allow these companies to provide critical tech to China? And why are ASML and TSMC so important to the US? How fast or powerful your computer or smartphone is for performing complex or multiple tasks, and how much power it consumes during use, mostly depends on how advanced the chip in your device is. This is true for almost everything, from calculators to supercomputers, and even for defense technologies like fighter jets. These devices are evolving over time due to modern complex chips made from advanced semiconductor technology. Semiconductors are the basis of devices like transistors, diodes, and integrated circuits. Integrated circuits, often called chips, are the most advanced and complex electronic components. They integrate multiple transistors, diodes, and other components onto a single chip. Each chip contains millions or even billions of tiny transistors and other components etched onto a semiconductor material like silicon wafer. The more transistors a chip has, the more advanced, faster, and efficient it is. For example, as of 2024, Apple's most advanced chip is the M3 Max, which contains 92 billion transistors, which is roughly 11 times of the human population on Earth. This is possible due to advanced manufacturing processes like lithography, which allow engineers to etch these tiny structures onto silicon wafers. By stacking multiple layers of transistors and using techniques like FinFETs, they can pack a massive number of transistors into a small area, which creates powerful and efficient processors. This process became complicated over time due to increase in number of semiconductors in a chip, which making it difficult for many players to compete in the development of advanced semiconductors and chips technology. Only few of them able to stay in the competition. One of them is TSMC, that is, Taiwan's Semiconductor Manufacturing Corporation. In 2023, more than 60% of the world's semiconductors and more than 90% of advanced semiconductors, which is crucial for high-tech electronics, were produced by TSMC. Even though TSMC was founded after its competitors like Samsung and Intel, it quickly established itself as a leader in the semiconductor industry and has consistently outperformed many of its rivals. There are several reasons why no one comes close to TSMC in terms of market share. TSMC's sole focus on manufacturing chips for other companies allowed it to concentrate on refining its manufacturing processes and technologies. While Samsung and Intel have to balance their foundry business with their own chip design and manufacturing operations, TSMC has a strong financial position, which allows it to invest in new technologies and expand its operations. Due to this, they are able to maintain their technological leadership, manufacturing efficiency, and customer satisfaction in the semiconductor market. As a result, many giant companies like Apple, Nvidia, Qualcomm, MediaTek, and AMD design their chips but outsource their manufacturing to TSMC on a large scale. In this way, TSMC is able to manufacture all types of semiconductors required for different types of chips used in various electronics. This dominance in semiconductor manufacturing has allowed TSMC to master the essential technology to produce advanced-level semiconductors, leaving no one even close to TSMC in terms of market share. So, right now, there is no doubt that TSMC is the master of advanced semiconductor technology, but it's not possible without a company named ASML. ASML, which stands for Advanced Semiconductor Materials Lithography, is a Dutch multinational company that designs and manufactures photolithography machines used in the production of advanced equipments like computer, smartphone, and GPU chips. In 1984, the company was started by Philips and chip machine manufacturer Advanced Semiconductor Materials International, known as ASM lithography at that time, to serve to the growing semiconductor market. The company began in a leaky shed next to a Philips office in Veldhoven of Netherlands, and has now become a company worth around $300 billion. In photolithography, light is used to etch patterns onto silicon wafers, defining the microscopic circuits that make up the chip. As chip makers wants to shrink transistor sizes to pack more onto each chip, the precision of lithography becomes increasingly crucial. EUV, that is extreme ultraviolet light, offers a solution, but it's not available on Earth. Sun naturally emits EUV light, but the Earth's atmosphere absorbs it before it reaches the Earth's surface. With a wavelength 14 times smaller than natural sunlight, EUV light is highly reactive and difficult to control. It's easily absorbed by most materials, including glass and traditional mirrors, and requires a vacuum environment to prevent absorption by air. Generating EUV light demands a massive amount of energy, which is challenging to achieve and sustain. Additionally, complex optics are needed to utilize this light effectively. These factors contribute to the complexity and high cost of EUV light manufacturing. ASML is the only company worldwide capable of producing EUV lithography machines. These machines generate EUV light, which is used to etch patterns on silicon wafers. These patterns define the smallest and most complex semiconductors, measuring 3 nanometers or less. This is equivalent to the size of a single DNA strand. EUV machines enable chip makers to produce smaller, faster, and more power-efficient chips, which are essential for next-generation technologies like AI, 5G, and autonomous driving. Due to the complexity of EUV machines, ASML has a near monopoly on advanced lithography machines. This makes ASML crucial to chip manufacturers like TSMC, Intel, and Samsung, which are the largest players in the semiconductor industry. Without ASML's EUV technology, these companies would be unable to push the boundaries of Moore's law, which refers to the trend of doubling the number of transistors on a chip every 2 years. Apple's A-series chips and NVIDIA's GPUs are examples of advanced chips manufactured by TSMC with the help of ASML's EUV lithography machines. Without ASML's EUV machines and TSMC's expertise, manufacturing high-end chips for future innovations in electronics would be challenging. The question arises, why did the US pressure these companies not to transfer high-end semiconductor machines or technology to China? Advanced semiconductors are crucial for military systems, cybersecurity, and advanced computing. The US is concerned that China's access to cutting-edge chips and the technology to produce them could enhance its military capabilities, including the development of autonomous weapons, surveillance technologies, and other defense-related systems. By restricting Chinese access to the latest chip-making equipment and manufacturing technologies, US seeks to maintain its lead in global tech innovation and prevent China from closing the gap in semiconductor production. Recently, China has invested heavily in building its own domestic semiconductor industry through initiatives like Made in China 2025, aiming to reduce its reliance on foreign technology. But China remains dependent on foreign companies like TSMC and ASML for advanced semiconductors and the tools needed to manufacture them. Chinese tech giants like Huawei have been targets of US sanctions due to concerns that their technology could be used for espionage or other security risks. These restrictions significantly slow down China's ability to produce the most advanced chips, forcing Chinese companies like SMIC to rely on older and less efficient manufacturing techniques such as 14 nanometer and 28 nanometers, while being cut off from cutting-edge technologies like 5 nanometer and below. According to some experts, China is at least 10 years behind in the advanced semiconductors race, even though the Chinese company Huawei manufactured a 7-nanometer chip for its smartphones. TSMC and Samsung are working on 2-nanometer semiconductor technology, which is way ahead than 7-nanometer technology. In future, only time will tell if Chinese companies can catch up with leading companies like TSMC and Samsung. If they fail, it is likely that the US will dominate with its giant companies in advanced technology across various sectors, unless the US removes these restrictions and bans on Chinese companies.